Hey there, class. Mr. Husky here. Hope you're having a good day so far. We're continuing with Chapter 7, and today we're talking about compositions of functions. This is 7.3, Day 2. Our essential questions are be able to determine the composition of two functions and be able to determine the domain of a composition of functions, okay? So, a composition of functions is basically when we take a function and we plug it into for x in another function, okay? So, yeah, that's basically what it is. It's going to be, composition means like composed or a couple things combined, right? So, yeah, let's go ahead and get right into this here. So, a composition of a function f of x with the function g of x is h of x equals f of g of x, okay? So, before that we had f of x. And now in this case, we have f of g of x, all right? Can also be written as, you can write it like this, as h of x equals, it's going to be f. Now, it's not an O, it's like a little circle right here. F composed of g of x. Okay, that little circle means composed of, all right? Or f of g of x. Okay, the domain of h of x is the set of all x values such that x is in the domain of g and g of x is in the domain of f. Okay? So basically, for it to be, remember domain restrictions are when we have zeros in the denominator, when we have negatives under roots that are even, right? So just be careful that the domains need to be true for the original functions as well as the compositions as well, okay? So let's get right into this here. So it says let f of x equal x squared plus 3 and g of x equal x minus 5. Find the domain of find each of the following and state the domain. It says start with the domain of each original function. All right. Well, we have f of x equals x squared plus 3. Do we have any denominator? No. Do we have any even roots? No. So the domain for this one's going to be just all real numbers. So that's one of our answers. What about the domain of g of x? Well, g of x is just x minus 5. Do we have a denominator? Nope. Do we have any even roots? Nope. So it's also going to be all real numbers. All right, so now we have f of g of x. What we're literally going to do, we're going to kind of work our way inside out here. We're going to take g of x, which equals x minus 5, and we're going to take that, we're going to plug into, so f of g of x is going to equal, we're going to take this x squared plus 3, we're going to take this, we're going to plug it in for x in the other equation, okay? So g of x equals x minus 5. We're going to take wherever we see an x in the other, in f of x, we're going to plug in x minus 5. All right. So let's write that over here, actually. Well, yeah, let's write that over here. F of g of x means plug g into f. Okay, it means plug g into f. So let's go ahead and do that. So we have f of g of x. Oops, not f of x. Equals, and we're going to plug in, wherever we see an x, we're going to plug in x minus 5. So we're going to have parentheses x minus 5 all squared plus 3. Now let's go ahead and simplify this here. So we need to simplify this. So we need to do f of, oops, I did it again. F of g of x. We have to expand x minus 5. There's two x minus 5s being multiplied together here, right? Plus 3. So f of g of x, dang it, I keep doing that. I like to write f of x it's more natural to me, I guess. Okay, so we're going to distribute that. So we're going to do like x times negative 5. We're going to distribute everything. You're going to get x squared. If you do that, you're going to get minus 10x. If you do the 5 times x and 5 times negative 5, you're going to get plus 25. Plus 3. All right, now we need to combine like terms. Got some constants that are going to combine here. So we have x squared minus 10x, and then plus 28. So what's our domain? Well, our domain would follow what the domain is for f and g. First of all, that was just all real numbers, and we don't have any denominators here. We don't have any roots that are even. So our domain is just going to be all real numbers again. So this is our final answer. This is our f of g of x equals x squared minus 10x plus 28 by plugging g into f, and our domain is all real numbers. Okay? Now we're going the opposite direction. Now we're doing g of f of x. So what we're doing for this is we're going to plug f into g. Okay, so in this case, f of x equals x squared plus 3 we're plugging into g of x, so in this case, which is x minus 5. So we're going to plug this into x there. Let me write g of f of x, actually. So you probably won't see what I'm writing until now. Okay. So g of f of x is going to be, we're going to plug x squared plus 3 in for x. So actually, this is just g of x. So let me fix that, actually. It is technically just g of x. G of x equals x minus 5, but we're going to take, so g of f of x means plug f of x in for g, so we're going to do x squared plus 3. It's going to go in for x, and then we have minus 5. Okay, and then we just simplify from here. So nothing to distribute, no like terms to combine. Well, I do have some like terms to combine. We got 3 and negative 5. So g of f of x equals x squared, and then 3 minus 5 is negative 2. So that is g of f of x is x squared minus 2. What's the domain? Do we have any denominator or even roots? We do not, and the original domains are just all real numbers, and the domain for this one is just going to also be all real numbers. So that's going to be your final answer. All right, so that's what it means to do composition of functions. All right, let's go ahead and move along here. We got 2 more examples to do. Let's go ahead and move to blue here. So we have let f of x equal 2 times x to the negative first, and g of x equal x squared minus 1. Find each of the following and state the domain. Start with the domain of each original function, and we'll go from there. So, well, I don't really like negative exponents for the most part. So we have f of x equals 2x to the negative 1. So I'm going to rewrite that. Remember, negative exponents are going to flip vertically, right? So we're going to move this to the bottom. So we can rewrite f of x equals just 2 over x, right? That's a better way to write that. It's probably a little bit easier. So what's the domain here? Well, the domain is going to be all real numbers, right? It's going to be all real numbers, except, are there any problems with this? Do we have a denominator here? Yeah, we said the bottom cannot be equal to 0. Well, x is the bottom, which x cannot be equal to 0. So that's going to be our domain right there, is all real numbers, but x cannot be equal to 0. Okay? Let's go ahead and find the domain of g of x. Now we have x squared minus 1, so no denominator. We have no even numbers, even roots. So it's going to be, domain is going to be all real numbers. Okay, which one's a little bit easier to do first? Why don't we try, well, if you want to give these a try on your own, see how you do. They're going to be a little bit trickier because we have 2 over x, and then we have x squared minus 1. But see if you can give these a try, and we'll go over them in a second. All right, so we have f of g of x. Are we plugging g into f or f into g? We are plugging, we work our way inside out, we're plugging g into f, right? So g of x is going to equal, it was x squared minus 1. And f of x was 2 over x. So we're going to take this x squared minus 1, we're going to plug it in for x in the bottom here. We'll plug it in wherever you see an x in the other equation. So f of g of x is going to equal 2 over, instead of x, we're going to plug in x squared minus 1. Okay? And that's f of g of x. That's as far as we can go. We can't simplify that. I guess what you could do is write this as 2 over x plus 1 times x minus 1, right? That's how you would factor difference of squares. You could write it like that if you wanted to as well. But let's look at the denominator now. Let's try to find the domain. So we set the bottom equal to 0, so we have x squared minus 1 equals 0, right? We have a denominator here, so we're going to add 1 to both sides. X squared, oops, I put minus 1. X squared equals 1. How do we solve for x now? Take the square root of both sides. So x is going to be equal to plus or minus 1. So what is our domain here? So that's our answers up here. What's our domain? Well, it's going to be all real numbers, but x cannot be equal to, what numbers do we have here? Well, we have, from the original problem, we have 0. X cannot be equal to 0, 1, or negative 1. All right, that's going to be our domain. It's all real numbers except it can't be 0, 1, or negative 1 because the 0 was from the original, domain from F. So you look at the domain from F and G and also from H. I guess I should have been writing H of X here, but that's not a problem. So, yeah, so the domain restrictions, it's going to be all real numbers, but X cannot be equal to 0, 1, or negative 1. And that's going to be our answer. Okay, this is our f of g of x, and then that's our domain restrictions. Can't be 0, can't be equal to 1, or negative 1. All right, sounds good. Let's talk about g of f of x now. Now are we plugging f into g or g into f? We are plugging f into g. So f of x equals 2 over x, and g of x equals x squared minus 1. So we're taking this 2 over x, we're going to plug it in for x in the other equation. So we're going to plug in this in for x right here. So we're going to have g of f of x equals, and then we're going to do 2 over x squared minus 1. So what is that going to be? Well, g of f of x is going to equal 2 squared is 4. You're going to apply the 2 to this and to that. So we're going to have 4 over x squared minus 1. All right, and then what's our domain restriction? Well, we have a denominator here. So we can't divide by 0, so we're going to set the bottom equal to 0. So x squared equals 0. Take the square root to solve. X cannot be equal to 0. So what's our domain restriction? Well, we already had x cannot be equal to 0 from the f of x. So our domain restriction is going to be, all real numbers, but x cannot be equal to 0. That was from f and from our g of f of x. And this is our answer. All right, so that is how we do compositions of two functions. Hope you guys have a great day. Thank you for watching, and we'll talk soon.